Okay, hello to Solveig and to Tyler and to Julia and to Brooke and who else is gone? Okay, we Solveig. All right, we hope you guys are doing well. We're not doing anything important today, just adding rectangles. So here we go. Here's the problem. Given a function, if you remember, we started Calculus 1 with a problem. The problem was, what is the equation for a line tangent to a curve at a given point? Remember that? And what we did is we took a secant line and a tangent line, and we used the secant line to approximate the slope of the tangent line. And we moved those points closer and closer together so that their distance apart approached 0. And we got that whole, limit as h approaches 0 of f of x plus h minus f of x all over h. But we didn't give that to you right away, right? You saw where it came from. So we're going to spend just 2 days showing you where this next formula comes from. And then you're going to see the formula. The reason why we spent more time on this, showing you where it came from, is because you didn't know anything about limits. So we had to introduce the whole concept of limits as well. Well, now we're adding up an infinite number of rectangles. So instead of the limit approaching 0, the limit's going to approach infinity. And you've already learned how to deal with limits as they approach infinity. You did that on your last test. So, but we do need to talk about how we kind of get around this issue. So the problem is really thus. We have this type of curve, and it's bounded by A and B. The question is, what is the area between function and the x-axis bounded by A and B? Now, obviously, there's lots of different types of functions. I've just drawn a basic one there, okay? Just something that has a curve to it. You can see it's the curve is smooth. It's differentiable the entire way. It's continuous. But, you know, that raises a really good question. We brought that up the other day, which reminds me I need to get some candy bars to you people who were so close in your guess. But we did this. Remember, we drew some rectangles. We even talked about the overestimation. We talked about the underestimation. And then we drew trapezoids in the end. So we're going to get to what we call left-hand sum, right-hand sum, and trapezoidal sums tomorrow. Today we're going to practice adding them up, and we're going to see how your calculator can be a great asset in this process as well. So, all right. Find the area bounded by the curve f of x equals x squared, the x-axis, and the line x equals 4 by constructing these. Okay? So we're just going to start basic. We're going to draw a parabola because that's the graph of f of x equals x squared. People struggle being able to draw the appropriate graph. I'm bounded by x squared, the x-axis, and what else? What is x equals 4? The vertical line is going to cross right through 4. I don't pretend that anything we do today is difficult. Okay? We're just going to be adding up rectangles. It's not tough. What you have to do is understand why we're doing it and just some of the little intricacies as I put forth. There's a rhyme and reason what I'm going to be doing up here. Okay? So, we're going to divide it into two rectangles. If we divide it into two rectangles, do you think it's a very good estimation? It's not. But if we divide it into two, I guess 4 divided by 2 is... So the width of each rectangle is 2. Okay. Now, here's kind of what you have to decide. How you're going to draw these rectangles. Will I draw them so the first one has a height here and the second one has a height here? Or will I draw it so the first one has a height here and the second one has a height here? See the difference? I'm going to start what we call a right-hand sum, a right-hand triangle drawing. And what that means is, as you look at each of these widths, each of these intervals, so to speak, we're going to go to the right-hand side of that interval, okay? So I'm going to go to the right-hand side of the interval, and I'm going to draw this rectangle to the function, and draw it over just like that. Very good. I will go to my second interval between 2 and 4. I will go to the right side of it, which would be 4. And I will draw a rectangle to the top, over, and down. What you think? Overestimation, underestimation? Hello, Julia! Welcome. Mikasa Sukasa. Overestimation, underestimation. Bad overestimation, isn't it? Okay. Well, we're going to approximate the sum right now, so we got to find the area of the rectangles. How would you find the area of this rectangle right here? So 2 being the width, right? So, yeah, 2 times, where'd you get 16 there, Emma? 4 squared. You plugged 4 into the function, didn't you? Wasn't f of 4 our height? And we're going to add that to 2 times f of 2. So f of 4 was our height for the big rectangle. And in the smaller rectangle, you had a height of f of 2. And so as Emma said, we have 2 times 16 plus 2 times what? 4. So I get 32 plus 8 is 40. And you guys all agree that that's an overestimation, right? I would agree. As I increase it to 4 rectangles, what changes with the problem? Yeah, I have 4 heights as opposed to just 2 heights. My width changes from 2 to 1. So I'm going to multiply all of my heights by 1. So doesn't it make sense that every time you find the area of a rectangle, you do multiply it by the same width every time, don't we? So really what I could do here, instead of a formula like that, what I could do is I could write this. Width times the sum of the heights. I could just factor that width out to the front, right? You don't have to worry about that all the way through. What's the width in this scenario? Just 1. So we have 1 times. Now we're going to have to figure out how to evaluate our heights. We're dividing this up into how many? 4. So we'll use green for this one. So I have 3, it looks like, and I have 1. So we're going to go to our first interval right here. Okay, I'm doing a right-hand sum. So from my interval, I go to the right side and I draw the rectangle up. Okay, I have my width up front here. I just need the height. How do you calculate the height? F of 1. Plus, now I look at my interval between 1 and 2. I go to the right-hand side, which is 2, and I move it up and over. So that would be f of 2. My interval between 2 and 3, I draw it up and over. So that'll be f of 3. And then 3 and 4. Okay. So what is f of 1? 1 plus 4 plus 9 plus 16. Well, that's 30. Times 1 is 30. So if you look here, do you think that that's a better estimation or a worse estimation? Better. As you notice, we cut off a total of 10, didn't we? You can even see the region. See this red region right here? We eliminated that. And then this red region right here, we eliminated that. Okay? Let's do one more by hand, and then I'll show you how you can do some of this using your calculator and make it a little bit quicker and be able to come up with a really, really good estimate. Okay? I'll use black here. I have 8 rectangles. 8 rectangles. What is going to be my width? 1/2. How did you get 1/2? Yeah. So you looked at your distance. 4 to 0 is a distance of 4, and you divided that by 8, right? So you looked at your total distance here, which was 4, divided by 8. So you got 1/2 is the width times the sum of the heights. So now we got to compute all, the spots where you evaluate the height. So I'm going to divide this up into 8 parts. So you got 1.5, 0.5, 1.5, 2.5, 3.5. So I'm going to draw my rectangles between 0 and 0.5. I draw the rectangle at 0.5. And I draw one at 1. Draw one at, draw one at 1.5. 2. 2.5. 3. 3.5. 4. Kind of hard to see on your sheet, isn't it, after a while? So most important thing is you kind of see what's happening here. Is that kind of nice, though? You see the change from the red to the green to the black. You see how it's becoming more accurate. And now we need to calculate the heights. So if we want to do the heights, that would be f of 1/2 plus f of 1 plus f of 1.5, f of 2, f of 2.5, good boy, f of 3, f of 3.5, and f of 4. Okay. Ugh. See how this could get kind of boring after a while, don't you? So we'll try to come to a quicker way to work through this. 1/2 is my width. A lot of people forget about the width. Can't forget about it. 1/2 is my width times the sum of the heights. 1/2 squared is 1/4. 1 squared is 1. We'll write it in fourths. 4 fourths. 1.5 squared is 9 fourths. 2 squared is 4, so 16 fourths. 2.5 squared is 25 fourths. 3 squared is 9, or 36 fourths. Very good. 49 fourths. And 4 squared is 16, or 64 fourths. All right, let's add them up. 1 plus 4 is 5, plus 9 is 14, plus 16 is 30, plus 25 is 55, plus 36 is 91, plus 49 is 140, right? 140 plus 64 is how much? 204. So 1/2 times 204 over 4. Can you divide 204 by 4? 200 divided by 4 is 50. So 204 divided by 4 is 51. And 1/2 of 51 is 25.5. Are we getting closer? We sure are. You know what? The actual number is 21 1/3. So we're getting close. Getting close. Wouldn't it be a pain in the butt to do 16? Let's use our calculators. Please write this down right here. Y sub 1 equals function. Then we go width times sum times sequence. And here's what you type in. I'll show you how to do it all. Y1, comma x, comma beginning, comma end, comma width, parentheses, parentheses. I'll show you. Trust me, you'll get it. Before you do anything with calculator, just watch what we're doing and see how this makes sense, okay? Let this make sense to your brain. Look at what we did here. See the 1/2? That was our width. So we put our width out front. Sum means addition, right? We added up all of the heights, right? Well, every time we added up the heights, look, we went from 1/2 to 1 to 1.5 to 2 to 2.5 to 3. I mean, there was kind of a pattern there, right? That's what we call a sequence. So the width times the sum of the heights. Now, what we do is we put y1, we put our x squared into our variable there. This is just telling it that we're using the variable x. Your calculator wants to know what variable you're using. We're using x. We tell them where we begin. So we began at 1/2. We ended at 4. And what was the increment each time? 1/2. So let's try for 8, and then we'll do it for 16 to make sure we end up with the same thing. So I'll show you how to find this stuff. This will save you some time, and you will have to do this on your test. Okay? So sy equals, and that's where we type in our function. What's our function? X squared. Now that you got that, you can exit out. And now we type in our formula. What was our width? 0.5. Sum is a command that we need to be able to grab. I like to grab all my commands from my catalog. So I go second, 0. That brings me to my catalog. Once I'm in my catalog, I can press S for sum. And I'm going to scroll down until I find the sum command. There we go. I guess you could go T and then back up one. That would probably be quicker. Huh? I'll do that from now on. Everybody see sum? We press enter. Now I need sequence. So I go second, catalog, S for sequence. And there's a couple sequence ones in here. We want the SEQ, that's small, with the parenthesis there. Sum of the sequence. Now what? Y1. Do you see a Y1 anywhere? That's the tricky part. Everybody gets messed up. That's a variable. So we want to, like, we know where x is, right? Yeah, that's right there. But we don't know where the y1 is. So that's what your vars thing is for. Vars, y vars. We want our function ones, don't we? And there it is. It's my y1. So we grab it. If you can get through that, then you're golden. Okay. Yep. We'll show you how to do it. Comma. Now it's a piece of cake. What? Comma's right above the 7. What is our variable? X. Comma. What's our beginning? 1/2. Comma. Where should we end? 4. Comma. What is the change each time? What's 0.5? Same as our width. Parentheses. Enter. 0.5. Now, can I show you a trick here? Let's say you wanted to do 16. Watch this. Everybody watching? Second entry. Whoa. Second enter, and the entry comes back up. Now I could just change the way I want to. But we want practice, so we're gonna try again. Okay. So let's try to write the one for 16 first. Okay, folks. All right. Let's write the one for 16. Okay. What is our width going to be? 1/4. Very good. 0.25. 1/4 times the sum of the sequence of our function y1, comma, x, comma, any idea what our first spot will be? 1/4 or 0.25. Not always. Only because we're starting at 0. If we were starting at 1, it would be different. If we bounded from 1 to 4, yeah, you'd have to add the 1 on. Very good. What's our last spot we'll go to? 4. And what's our change, our increment of change each time? 0.25. So now that I got those pieces, I go back up here. My y1 is right there. Okay. 0.25. Catalog. I remember that the sum was really close to tangent. Yep, it's one right back from tangent. Now I grab my sequence. And how do I get my variable? Vars, y vars. You could very possibly just type in x squared, and that's shorter. Sometimes if it's a longer function, people don't want to type that in. I haven't actually tried typing in the function, but you very well might be able to. Comma. X is our variable, comma. 0.25, comma. 4, comma. 0.25, parentheses. Ooh. How do you like that? A little better? A little bit better? Flip it over. Here we go. Okay, let's switch it up a little bit. Now it's negative x squared plus 16. Okay. This is a parabola that's shifted up. 16 that's upside down. I want to find the area bounded by the x-axis and the y-axis. What do I need to know? Yeah, where does it cross right here? 4. Very good. If you solve that equals 0, you get 4. Two rectangles. So I take my width times the sum of the heights. My width is 2 times f of 2 plus f of 4. What is f of 2? What's f of 4? 0. So you get 24. Is that an overestimation or underestimation? Now it's underestimation. You can see if you're concave down, it's an underestimation in this scenario. If you're concave up, it's an overestimation. But it also depends on whether you're doing a left-hand sum or right-hand sum. So right now we're doing a right-hand sum. We got 24. We'll do this one by hand, and then we'll use our calculator for the next one. Okay. So what's our width this time? Our width is 1 times the sum of the heights. So first I will do f of 1 plus f of 2 plus f of 3 plus f of 1 times 15, 12, 7, 34. So that's better, isn't it? I don't really want to do that 8 times, and I don't want to do it with fractions. So let's write our formula. What's going to be the width? 1/2 times the sum of the sequence of y1, comma x, comma, what is my starting point? Point 0.5. Because when I drew my rectangle, I would have an interval from 0 to 0.5, and I go to the right-hand side. So right now, we're always going to the right-hand side. If you did 0, you would be doing the left-hand side. And we'll talk about left-hand side tomorrow. So I got 0.5. What's my last one? 4, which is always, in this case, when we evaluate 4, we always get 0. So, and then I put my increment, which is 0.5. So I'll do my second entry to get back what I had before, in case you want to type it all in. And I could get rid of that piece right there. Looks like I got my y1, I got my x. Yep, I will do that. 4, delete. So now it looks like everything's pretty good. So if you do your second entry, again, you can grab that previous piece. And If I go back in my y1, I do have to change that to negative x squared plus 16. So now I'm back here, and now everything should be entered correctly, and I got 38.5. Does it make sense that it should be going up? Because it's an underestimation, so we should be getting closer and closer and closer. Yeah. Sure. Yep. Exactly. Exactly. Can we do one? Not one more problem, but can we do something that's just totally fun? Let's do 400 rectangles. If we're going to divide up into 400 rectangles, what's the width of each rectangle? 100th. 1/100th times sum of the sequence of y1, comma x, comma, we're going to start at the width, 100th, 0.01 to 4, and each increment is going to be 100th. I'll grab my entry. Looks like I gotta insert a 0 there. And oh, it's got to think really hard, doesn't it? Poor calculator. Mine's a TI-83, so that if you got a TI-84 with a lot more memory, you might be able to do it really quickly. Like we went to 1,000, you might actually be able to watch a whole commercial or something by the time. 42.5866. Isn't that neat? We made our calculator really actually think about it a little bit. So we're getting closer. My guess is 42.58 is probably really close. Okay. Last thing, take out your calculator, go to y equals. You know how to check to see if you're really close since you don't know the calculus yet? Go second calculate. And you don't know this button yet, do you? 7. You know value, you know 0, min, max, intersect. dy over dx was your derivative. 7's your area. Grab 7. What's the start of our boundary? We went from 0 to 4. So we go lower limit is 0, press enter. Upper limit is 4. And watch it draw the rectangle. Is that cool? Well, and technically your calculator is an estimation. It is exactly 42 2/3, and we're going to show you how to find that in a few days. But right now, we came up with 42.5866. Now you can't just do that on your test, but that's a way to at least check to see if you're doing it in a reasonable manner. Here's all I want you to do, folks. Okay, I want you to just do 3 and 4. That's your homework. That's all I want you to do. Now, when you do 3 and 4, okay, always do the first one by hand. If you want to do the next ones with your formula, go ahead. Always do the first one by hand so you make sure that you're doing it appropriately. Because trust me, when you do it by hand, you'll understand how to, because we're going to do an infinite number of these. We're going to do infinity on Wednesday. We won't do 400 rectangles. We'll do infinite number of rectangles. Oh, 2 roots of x? That's exactly what you had on Friday. Remember the graph on Friday I gave you that we estimated by hand? That's what you want. A second place prize? Oh, maybe a pat on the back here. I'll come give you. I think I probably should. Maybe I should just bring candy for everybody again.